sklearn, model selection, GroupKFold. Description: GroupKFold is a cross-validation strategy that preserves the structure of the data by ensuring that all samples from the same group are in the same fold. This is particularly useful for datasets where the groups represent different conditions, individuals, or other meaningful units. Inputs: N splits the number of folds to be created. Shuffle whether to shuffle the data before splitting into folds. Random state the seed for the random number generator used for shuffling. Outputs: split a generator that yields the indices of the training and testing sets for each fold. Steps: group the data based on the provided group labels. Create folds by evenly distributing groups across the folds, ensuring that all samples from the same group are in the same fold. For each fold, yield the indices of the training and testing sets. Metrics: not directly applicable to the GroupKFold class itself, as it only provides a mechanism for splitting data. However, you can use these indices to evaluate the performance of your models using various metrics. Visualization plots: not directly applicable to GroupKFold, but the resulting folds can be used to visualize data distribution across groups using techniques like box plots or scatter plots. Fine-tune parameters: N splits adjust the number of folds based on the size and complexity of your dataset. Higher values typically lead to more robust evaluation, but may take longer. Shuffle: enable shuffling if you want to randomize the distribution of groups across folds. Random state: set a seed for reproducibility, ensuring consistent folds across runs. Uncertainty methods: not directly applicable to GroupKFold. Uncertainty methods are used for assessing the confidence in model predictions, which is a separate process after training. Challenges and fixes: Challenge 1: uneven group sizes if the groups have significantly different sizes. Some folds might have more data than others, potentially leading to unbalanced performance evaluation. Sample use case that resulted in Challenge 1: a dataset where groups represent patients with different disease severity levels. Groups with more severe conditions might have fewer samples than groups with milder conditions. Fixes to Challenge 1: consider using stratified sampling to ensure proportional representation of groups across folds. Adjust the N splits value to account for group sizes. Challenge 2: limited groups if the number of groups is relatively small compared to the number of samples. The number of effective folds may be limited, reducing the reliability of cross-validation results. Sample use case that resulted in Challenge 2: a dataset with only 5 different user groups, but thousands of individual user samples. Fixes to Challenge 2: consider using other cross-validation strategies that don't rely on group structure if appropriate. Use a larger N splits value to compensate for the limited number of groups.